Whales go quiet worldwide. A chilling silence beneath the waves. Blue whales stop singing as climate crisis deepen. A mysterious and ominous silence is spreading through the world's oceans as blue whale, Earth's largest and most majestic creatures, have dramatically reduced their iconic song. Scientists now warn that this phenomenon could be a grave signal of deeper ecological disruption fueled by climate change. Now let's unravel the full story in today's AI podcast episode.
Imagine the deep ocean, usually humming with sound, clicks, whistles. But now, parts of it are falling silent. Today, we're diving into something quite unsettling, really. Earth's largest creatures, the blue whales, well, they're singing much, much less. It feels like a chilling silence beneath the waves, maybe even an ominous signal. So our mission in this deep dive is to unpack why. What's causing it? What does it tell us about the ocean's health? And maybe about ourselves.
Yeah, it's deeply concerning. And what's really striking is how this specific change, this quietening of the whales, connects to, well, much bigger ecological shifts. It's almost a case study in how one disruption can ripple outwards in ways you might not expect. We're hoping to help you connect those dots today.
Okay, so let's start with what scientists actually observed. Researchers at MBARI, the Monterey Bay Aquarium Research Institute, they noticed this really sharp drop in blue whale calls.
That's right, specifically off the coast of Monterey Bay, California. And the number is quite stark, nearly a 40% decrease in their vocalizations.
40%. Over what kind of time frame are we talking?
Just the last 6 years. It's a pretty rapid decline in the grand scheme of things.
Wow. Okay, so how do you even listen for silence or less sound in the middle of the vast Pacific?
All right, it sounds tricky, doesn't it? They use these amazing pieces of technology called hydrophones. Think of them as underwater microphones.
Okay.
And these aren't just dropped off a boat. There's a massive setup, a 32-mile-long cable stretching out into the ocean, going down deep.
32 miles.
Yeah, and reaching nearly 3,000 feet below the surface at its deepest. So these hydrophones are constantly listening, recording the ocean soundscape year after year. That's how we get this incredible long-term data.
Incredible, 3,000 feet down. So they're picking up these whale songs, these low-frequency sounds. Why are those songs so important for the whales in the first place?
That's absolutely crucial. These aren't just random noises. They're songs. These really low-frequency calls are essential for, well, everything. Communication across vast distances, navigation, and especially for finding mates.
So if they're not singing...
Exactly. If they're not singing, or singing much less, it throws a huge wrench into their social structure, their ability to reproduce. It's why this silence is setting off such serious alarm bells for scientists.
And the really strange part, as I understand it, is that the scientists weren't even initially trying to measure whale song levels with these hydrophones.
You're absolutely right. It's one of those slightly unsettling, unexpected findings. The hydrophones were originally put there to monitor human noise, ship traffic, maybe sonar, things like that.
Right, the human impact.
Precisely. But instead of just finding evidence of human activity, they stumbled upon this other, arguably more worrying trend. The loudest natural sounds were fading. The ocean wasn't getting quieter because we were being less noisy.
It was because the whales were.
Exactly. It pointed towards a much deeper systemic problem within the ecosystem itself.
So if they're going quiet, and it's a serious problem for them, what's the likely cause? Is there a smoking gun, so to speak?
There is, yes. The timing lines up almost perfectly with a major environmental event known as the Blob.
The Blob. Sounds a bit sci-fi.
It does, doesn't it? But it was very real and devastating. It was a massive marine heat wave. It first showed up around 2013.
Okay.
And by 2016, it had spread across thousands of miles of the Pacific Ocean. Just this enormous patch of unusually warm water.
How warm are we talking?
Significantly warmer. Ocean temperatures rose by over 4.5 degrees Fahrenheit in that area. And that kind of change, sustained over that scale, is enough to completely throw marine ecosystems out of whack.
Right. 4.5 degrees doesn't sound like much, maybe in air temperature day to day, but in the ocean.
In the ocean, that's a massive shift. It changes currents, nutrient availability, everything. John Ryan, he's a biological oceanographer at MBRI. He put it very starkly. He said, the blob caused the most widespread poisoning of marine mammals ever documented. These were hard times for whales.
Widespread poisoning. That's intense. How did the heat directly lead to poisoning, or was it more indirect?
It was more of a cascade effect, really starting with the base of the food web. The warm water created ideal conditions for harmful algal blooms to just explode.
Okay, those toxic algae blooms we hear about sometimes.
Exactly. And these blooms absolutely decimated krill populations. Krill are tiny crustaceans, but they are the primary food source for blue whales, and fin whales too.
So the whale's main food just disappeared.
Pretty much vanished in many areas. John Ryan mentioned that in normal years, krills are so thick they can actually dye fishing nets pink when fishermen pull them up.
Wow.
But during the blob years, they were practically gone. And Ryan had this really powerful way of putting it. It's like trying to sing while you're starving.
That makes perfect sense if you're spending all your energy just desperately searching for food.
There's nothing left for singing, for mating displays, for those long migrations. Their whole energy budget just shifted to survival mode. Singing became a luxury they apparently couldn't afford.
And it wasn't just that the krill numbers dropped, right? I remember reading that the heat changed things in other ways, too. Kelly Benoit-Bird, another MBRI scientist, said something like, the whole system changes.
That's a really critical point. It wasn't only about the amount of krill. The heat wave also messed up the ocean's natural upwelling process.
Upwelling. That's when the colder, nutrient-rich water comes up from the deep.
Exactly. It's like a natural conveyor belt bringing nutrients and often concentrated patches of krill towards the surface where whales feed. But the heat wave disrupted that process.
So even the krill that were left were harder to find.
Precisely. They became more scattered, less concentrated, making it even more energy intensive for the whales to hunt them down. So the whales didn't just choose silence, it was almost forced upon them by hunger and stress.
That stress factor seems huge. John Ryan also said, we don't hear them singing. They're spending all their energy searching. That tells us those years are incredibly stressful.
Yes, it's a direct measure, in a way, of the pressure these animals were under. Just surviving took everything they had.
And like Kelly Benoit-Bird pointed out, if animals as huge and wide-ranging as blue whales, they can travel the whole West Coast if they can't find enough food. That signals a problem on a massive scale.
A really large-scale consequence, as she put it. It tells you the disruption isn't just a small, local blip. It's affecting the entire structure of the marine environment over vast areas.
Which leads to the question, is this just a California thing? Or are we hearing or not hearing this elsewhere?
Yeah, that's the concerning part. It's definitely not isolated to Monterey Bay. Similar drops in whale songs have been reported in other parts of the world, too.
Really? Where else?
We're seeing reports from across the South Pacific, down in the Southern Ocean near Antarctica, and even off the coast of Argentina. It seems to be a more global phenomenon.
Is there specific research confirming this pattern in those other places?
There is. A really compelling study came out of New Zealand from the South Taranaki Bight. A team led by Don Barlow from Oregon State University was studying blue whales there between 2016 and 2018.
Okay.
And kind of coincidentally, their study period ended up overlapping with marine heat waves in that region too, so they inadvertently captured the effects.
And what did they find? Similar silence?
Very similar patterns. They were tracking specific types of calls, D-calls, which are linked to feeding behavior, and also the more rhythmic songs associated with mating.
And
both types dropped significantly during the warmer years, during the heat waves. The implication was pretty clear and worrying.
they weren't feeding as much, and they weren't singing mating songs as much either.
Exactly. It suggested they were putting less effort into both feeding and reproduction. As Don Barlow put it, when there are fewer feeding opportunities, they put less effort into reproduction. It's a warning.
A warning sign. It really paints these whales, these giants, in a new light. They're not just impressive animals. They're like indicators,
Right.
sentinels.
That's a perfect word for it. Sentinels. They are living indicators of the ocean's overall health. Because they're so large, long-lived, and travel such vast distances, their behavior, their health, their very presence or silence reflects what's happening in the entire ecosystem on a grand scale.
So when they go quiet.
When they go quiet, it's more than just their own struggle. It really is like a cry for help from the ocean itself. It signals deep, complex, and potentially dangerous changes underway.
Dawn Barlow had another quote, didn't she? Something about what they tell us?
Yes, she said, where they are and what they're doing tells us a lot about the health of the ecosystem. And right now, they're telling us something is very, very wrong.
Something is very, very wrong. Okay, so let's just recap the core message here. This eerie quiet from the blue whales, it's not some random mystery. It's a direct, measurable result of our planet wilting up, particularly the oceans.
And the way that heat is fracturing the marine food web, starting right down at the bottom with things like krill.
The effects of the heat, like the blob, are literally echoing through the deep now, but as silence.
It's a chilling thought, isn't it? And it leaves us with a pretty stark question to ponder, one that was raised in the research itself.
Which is,
If the largest animals on Earth, these magnificent blue whales, can't thrive, maybe can't even survive, in our rapidly changing oceans, what does that mean for everything else living there?
and ultimately, what does it mean for us?
Exactly. It's a profound signal, the time to really listen to what the ocean and these whales are telling us. And maybe to act. Well, that time is definitely now.
Okay, one question for you. What does the silence of blue whale reveals about the broader impacts of climate change on marine ecosystem? Don't forget to comment it. Thanks.